Okay, so day 2, we are going to start day 2 of advanced math topics. We're going to start with polynomial functions. Okay, so these are polynomials to where if graphed, they look like the following. Just real quick. So cubic, you have this quartic, and you have this quadratic. This is x cubed. This is x to the 4th. This is x squared. This means, like we talked about last time when we were doing quadratics, this has two solutions. Whether they are two real, like distinct, whether there are one double root, which is the same answer, but you're accounting for it twice, or whether it has two non-real solutions. These are the imaginary i's where you don't cross the x-axis. You with me? The change of direction is always one less than the power. So x to the 4th, I'm teaching this to you guys, and a lot of you might not have been exposed to this at all because you're going to be exposed to it in pre-calc. But I want you to learn it still because it is a good strength. This is x to the 4th means that there are 4 answers. 1, 2, 3, 4. All of these are real. It could be 2 real solutions and 2 imaginary solutions. You with me? As long as there's 4 answers. And how many changes of direction? It's always one less than that degree. So there are 3 changes of direction. And then just 1 change of direction. X to the 3rd, 2 changes of direction. And there are 3 roots. Look, 1, 2, 3. There's the double root. This is big, because a lot of you have never seen this before. Now watch. 1, 2, 3. Let's say that this is x equals 3. The way you would write that as a factor would be x minus 3. You with me? This is x equals 0 twice. So you're going to write it as x squared. This is how you would build this function from scratch. You with me? Now watch. Powers that are odd, like 1, 3, 5, 9, 7, all that stuff, will go through the x-axis. It'll cut through. But powers that are even, 2, 4, 6, 8, whatever, will bounce off the x-axis. At that location, they'll bounce off. Are you with me? All right. So over here, I have x is equal to, negative 1, 0, 1, and 3. Negative 1, 0, 1, and 3. So if I were to write these out, negative 1 looks like this. 0 looks like this. Positive 1 looks like this. And positive 3 looks like this. Notice how the power is still to the power of 4 if you were to distribute all of those pieces out. So that means that there are 4 real, or 4 solutions. Whether 2 are real or all are real, there's going to be 4 solutions.
You left my number cruncher. If I get it spare.
Not for today. I'm sorry. I don't have time. All right. So 4 answers, 3 changes of direction. This is how I build it right here. And can someone tell me what are the powers that you see of all these pieces? 1. So it cuts through. It doesn't bounce off the graph. Are we good? Okay. Now, here's the question. How do you know if a graph like this one, how would I know whether it's going to go up as I go to the right, or whether it would have been like this, going down as I went to positive infinity? Here's the thing. I need to look at the signs of all of these coefficients. Positive, 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 positive. If I were to multiply all that out, I would get a positive x to the 4th. Are you with me? So if I get a positive coefficient with my biggest power, that means as I go off to infinity, it will go up. Okay? This is x to the 4th. The last thing, guys, since this is even, an even number, as I went to negative infinity, it will basically look, it'll almost look like a mirror image. You with me? But if it's an odd number, it wouldn't have gone up to the left. It would be basically diagonally from what this is. looks like here in just a bit with some examples. Pretty much, we just went over all of that in a nutshell. Now let's go to the practice. All right, so here we go. So find the real zeros of the following function. You can definitely factor, for sure. And your first factor is GCF. What do you see right now? X. So f of x is equal to x. What's left over is x squared plus 7x plus 6. And yes, we could factor this to x plus 6, x plus 1. Here's your x, and you set it equal to 0. Go with me? Now let's graph this. You just learned how to do that, and I will reinforce that now. Please make sure that you understand. The first 0 is going to be at 0, and then negative 6, and then negative 1. Now I have to decide. The biggest power was positive, and this is the order that I think you should always do it in. So the biggest power is positive, x cubed. You with me? So that means as I go to the right, I'm going to go up. The fact that this is an odd number means if I go to the left, what am I going to do? I'm going to go down. Bless you. So now all I have to do is look at these powers, and if they're odd numbers, bless you, it's going to go through the x-axis. But if they're even numbers, it'll bounce off the x-axis. You with me? So all of these are all odd numbers. So it'll go through, and up. This is just a sketch. How many zeros do you see that I drew? 3, which makes sense. There should be 3. How many changes of direction do you see? 2, which is making sense. It's 1 less than the highest power. You with me? Okay, so find the real zeros. You would say 0, negative 6, negative 1. Any questions right now? I want you to know the graph. Trust me, it's a strength to have when you're looking at some of these questions, especially this weekend. Okay? All right.
Do you need a check for extraneous solutions?
Oh, love the question. In pre-cal, we're taught to check for extraneous solutions. The only time you have to check for extraneous solutions, the only time, is if in your entire equation you have any kind of parent function that doesn't have the domain all row numbers. That's the only time. If you remember back with square root of x, this parent function looks like this. The domain is not all row numbers. So whatever I mathematically solve for as far as zeros, I need to go back, and like Dylan said, I have to check my answers because the domain is not all row numbers. Who can tell me another parent function that you have to go and check your answers for extraneous solutions because the domain is not all row numbers? Logs. So natural log of x, we need to memorize. We should. This is 1, 0, because the natural log of 1 is 0. And there's a vertical asymptote at x is equal to 0, because the domain is everything above 0. You with me? So I have to check for extraneous solutions. There's another one that's common. Rational, 1 over x. And we know that 1 over x, guys, you guys, very, very nice on the parent function. Okay, that'll help you a lot on these kind of questions. Okay. So let's move on, and let's go to something that looks like number 2. So number 2, come on. So number 2 is a little bit different. If I asked you to factor it, what would y'all do? Yeah. When you see 4, make 2 pairs and factor them like that. If you see 3, then you're going to factor it to those 2 that we just did. Okay? So here we go. The GCF of this one is x squared. The GCF of this one over here is what? Negative 1. Nice. So what's left in parentheses? X minus 4, and x minus 4. Nicely done. These should be the same. Factoring by grouping. We've done this in algebra 2. This is one of the roots, and the other one is what's outside of parentheses. 3 words, I see it right now as I'm looking at this. What are the 3 words I'm thinking of? Difference of squares. So x plus 1, x minus 1, x minus 4, looking for the zeros at -1, 1, and 4. Do I need to check for extraneous solutions? No, because the domain of x cubed is all real numbers. All right. Let's do, all right, so let's do this one right here. So I'll let you guys do 3 on your own, but let's use this huge function right there. And we're going to check, is -2 a 0 of this function? In other words, is -2 an x-intercept of this function?
Yes.
Okay, so we're going to find out here in just a bit. If x equals -2 on a graph, looks like this. Bless you. Whoops. If x equals -2 is a 0 of this function, then that means what factor exists? X plus 2. Because remember, this is right here. That would make this, bless you, 0. Go with me? Synthetic division. Here we go. Synthetic division is a nice, efficient way to see, can something have a factor that looks like this? Go with me? Here we go. I'm going to list in descending order all of the x's all the way down to the constant. I'm going to look at the coefficients of these and write this down. It almost feels like solving systems of equations with Gaussian elimination, when you were just looking at those coefficients of each term. You all with me? With x and y and z and the number, you were just writing all the numbers in those matrices. Do you all remember what I'm talking about? This is what this kind of feels like. So we have 9, -9, -58. We have +4, and we have a +24. Let's say I didn't have this. What would I put instead of 4? 0. Good. All right, so we're going to check to see if this, x equals -2, is a factor of all of that. If it's a 0. Okay, my goal is to get 0 right here. If I do, then x is equal to -2 is a factor with no remainder. Okay, it's like division, long division, but way more efficient. First step, copy it down. Next step, multiply. And write it down right here. And then add. So I have -27. Multiply, I get a +50 what? 4. And then add. Get -4. Multiply, I get 8. Go with me? And when I add, 12. When I multiply the -2, I get -24. Ding, 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 ding. It worked. That means x is equal to -2 is a factor. So what just happened is I just reduced this whole thing. Now, look, here's the constant originally. Oops. Here's the constant now. Here's the x term originally. Here's the x term now. It's like you shift everything over 1 unit. So it's -4x plus 12, -27x squared, and a 9x cubed. All of this, because x is equal to -2 worked, this is the other factor. Now I know I'm giving you more. I know I'm giving you more information. We could just say yes because it gave us 0, but I want you to know what you're going to end up doing with this. Do you see how next you could pair these up and GCF and factor even more? Let's do that. What's the GCF in this first one right here? 9x squared. What's left? x minus 3. Oops. What's the GCF right here? Negative 4. What's left?
X minus 3.
There we go. There's your carbon copy. This is one of my factored answers. So I'm going to write x minus 3. What's outside of parentheses is the other thing that's written. And there are those 3 words yet again. Difference of squares. I still have this. Don't forget this. Right now, I'm almost factored all this out. Difference of squares. Here we go. Difference of squares. Oops. Oops. Come on. It will look like the following. This will become 3x plus 2, 3x minus 2. This is x plus 2. This is x minus 3. So all of these out, where does this go on the x-axis? Negative 2. Where does this go? Positive 3. Where does this go? 2/3. So 2/3 is almost 1. We'll just put a dot right there. And then this one? Negative 2/3. Let's graph it. We're doing this by hand. I'm teaching you something new. What number am I looking at right there? I'm looking at the 9 first. And the 9 is what? Positive. So that means as I go off to infinity, I'm going to go up. You with me? Step 2. Look at the 4. That means as I go off to negative infinity, where am I going to go? Up, because it's an even number. Now, all of these roots have a power that is what kind of number? Odd, right? It's 1, but it's odd. So it will go through the x-axis, not bounce off. So from the blue, we're going to go through, go back to go through, go back to go through, go back to go through. We have 3 changes of direction, which makes sense. It's 1 less. And it doesn't have to be. The most it can be is 3 changes of direction. It doesn't have to be 3 changes of direction just because it's 1 less. And I'll show you that here in just a bit. So let me ask you this. Is x equal to a 0 of this function? No. Okay. Is 2/3 a 0 of this function?
Yes.
Yes. What is the y-intercept? Guys, what could I do? What could I do to this right here or this right here to get the y-intercept? Plug 0 in for x. Look at that. 0, 0, 0, 0. The y-intercept is 24. This problem was awesome.
Question.
Yeah.
Could you also, so like I didn't, when I was just writing, so I just plugged in the values for x, and like,
To me, you want to develop synthetic division. You can plug in the values for sure. But you want to develop synthetic division because your speed when you do that other thing of just plugging in is already going to be faster. But if you have a problem, see, on the test, remember how at the very end I got 0 on the bottom? On the test, they like to say, you have this equation, but b is right there. Instead of 58, b is there. Solve for b. Synthetic division you would need to solve backwards so that you could solve for that b. That knowledge you would need. Or you do a lot of plugging chugging. The plugging chugging will work, but you're losing time. And if you use pre-cal knowledge on something that's just from Algebra 2 stuff, you're ahead of the game. You're stronger than those who just got out of Algebra 2. Or there's some people that are taking Algebra 2 this year as juniors that are going to still be taking that PSAT. Okay? Alright, so just more tools in your arsenal. Questions. So, for instance, look, here's the example right here with B. This is why I want you to learn synthetic division. Let's do, and this will be our last one, then we'll move on to the other sections for today. Let's do number 8. it says g is defined by all of this. Okay? And it wants to know what is the value of b if this is an x-intercept. Now you could use synthetic division for sure. You could say 3b 33 negative 9. And if it's saying that this is an x-intercept, you would put negative 3, or sorry, not negative 3, you would put 3 right here. Are you with me? So solving backwards, if this is 0, what does this have to be right here? 9. So if this is 9, what did this have to be multiplied to get that? 3. So if this is 3, what did this have to be so that when I added them, I would get a 3 there? Negative 30. So if this is negative 30, what does this have to be when you multiply, you get negative 30? Negative 10. So you'll see what I'm going with this? And now I'm going to meet it halfway. I know the first step is copy. So what am I going to write right here? 9, because 3 times 3 is 9. So you would say b plus 9 is equal to negative 10. What's b, guys? Negative 19. I know that there's another way to do this. But learning the synthetic division does help a lot, okay? The other way to do it would be to plug in 3 where x is at. You with me? So I'm going to plug in 3 right here, here, here. Where am I going to plug in the 0? Y. So it'll be 0 is equal to, what's 27, right? 27, that's 81. So 81 plus 9b plus 99 minus 9. So you see 90, you see 81, there's 171. If you subtract it over, and you have 9b left over, and you divide by 9, you're still going to get negative 19. Either way. See what I'm saying? Where's your algebra faster is what we're trying to develop and refine. All right. Review. When bases are multiplied, bases that are the same are multiplied, add the powers. When they're divided, we subtract the powers. Otherwise, I like to think of it like this. Instead of the subtracting, I don't like the subtracting. I don't. I like this. I know that there are 5 up top, there's 2 on the bottom. Cancellation forms of 1. Who wins? The top. By how much? 3. But then I have to remind people, what if you had it like this? You would have 2 on the top, 5 on the bottom, and cancellation to forms of 1, 3 are left on the bottom. If you use this rule of subtracting when it looks like this, it's basically going to say 2 minus 5, which is the same as negative 3. And x to the power of negative 3 is the same as 1 over x to the positive 3. We learned that in Algebra 2. We good? But a lot of people forget it, so please put that back in your short-term memory. Powers raised to a power we multiply. The easiest way to see that is there's a parentheses between the 2 and 3. Parentheses, 9 out of 10 times means to multiply. Anything to the power of 0 is 1. And then last but not least, roots are on the denominator and powers are in the numerator. Okay? So let's say that I had for you 81 to the power of 5/4. What should we do? We have 2 options. We can take 81 and raise it to the 5th power and then take the 4th root. Hopefully no one wants to do that. Or we could take the 81's 4th root and then raise that to the 5th. I hope you do that. Because you're breaking it down per the denominator to the lowest root possible. Guys, what's the 4th root of 81? 3. Now 3 to the 5th power basically saying what? 81 times 3. So 243. Okay? Alright, so let's keep going. Let's look at, okay, I'll let you pick one problem. 1 through 7. Which one do you want to do? 5? Or 4? Which one? I think I heard more 5. 8 to the power of 0 is 1. So 1 times x to the negative 2 is the same as 1 over x squared. This piece, this negative 4 is applied to what? Is it applied to the x or the 5 and the x? It's just the x. Because if it was applied to the 5 and the x, it would look like this with parentheses. So let's move this to show 5 over x to the 4th, which will be multiplied with 3x squared over 1. Who wins from the x's? The bottom by how much? 2. 15's left up top. Can I add these? Yep, because of common denominators. There's your answer. Remember, this reduced. This right here reduced to that. Any other ones that you want to do from 1 through 9? Yeah.
About the one from 8 to the power of 0.
8 to the power of 0 is 1.
That's multiplied for.
Yeah, no worries.
So you multiply the 1 times the x to the negative second.
To me, I like to change the negative powers as fast as I can and make them all positive, and then ask myself who wins. Okay? Another one, guys. Which one do you want to do? You want to do 4 since y'all were saying that before? Alright, so this is how I would do number 4. 4, you can distribute that negative 1 on everything first, or you can work with the stuff on the inside. To me, I like to distribute this first, so that I see a to the negative 3, b to the positive 2, a to the positive 4, c to the negative 2. And it tells me that the c will move up, the a will move down, so that when they move, they become positive. Everything else stays exactly where it's at and stays the same. You with me? What do I do from here? I cancel, reduce whatever I can, right? What's the numerator going to reduce to? Just what it is, right? B squared, C squared. What does the denominator become? A to the power of 7. Move the negatives and then see who wins. Okay? Alright, so let's keep going. Any one of these 4 that you guys would want to work out. I'll do one more. 13. 13 says the following. What does z to the 6 equal in terms of x and y? So first of all, I have, so to me, I don't know, it just looks weird when it's slanted like that. And I'm trying to get something to say z to the 6th. You with me? How can I get the right to say z to the 6th?
Well, multiply it times
Multiply it by, well, not multiply it, but,
c to the third over 2.
so it's not going to be multiplied by z, because then you have to do what to the powers? Add. So we could also do something that looks like this. Because here's the thing, that's a good suggestion. You could multiply by z squared, because now you have z to the 6th. But look at the left. You have to multiply this by z squared. You with me? Is this in terms of x and y? No, it's in terms of x, y, and z.
Could you raise it to the 3rd?
There we go. So we're going to raise it to the 6 over 4 or the 3 over 2. Same thing. Do you see why I said 6 over 4? Because the 4's would cancel to 1, and there's your 6. But I like the 3 over 2 because it's still going to simplify to the same thing. So let's do raise it to the power of 3/2. So that multiplied, there's my 6. There's the 6 that I needed. And now I'm just going to treat this like any other problem that we did from before. A power raised to a power, what do? Multiply. So it'll be x to the power of, watch, so 4/3 times 3/2. I'm going to look at this and be like, ooh, those simplify to 1. This simplifies and brings it down to 2, so it's x squared. Now I'm going to do 2/3 times 3/2. That's an easy one. What is that? 1. X squared y. Cancellation forms of 1 are everywhere, and I keep trying to help you guys with that. Find them, look for them, make it easier for yourself so you can easily do well on those non-calculator portions. Operations with rational expressions. It's all about the LCD on this one. The least common denominator. Okay? So simplify the following using required operations. First of all, let me ask you, which one do you want to do? I'll let you pick. Number 6. 6 is a good one. I have k minus 1. I have k minus 6 plus 1. And then I GCF the bottom. Oops, something's wrong. It's not minus 6 plus 1. What is it, guys? Yep. Nicely done. And here's a good FYI. A lot of times, that's when I caught my mistake. Because I'm used to those canceling of some sort. So when I didn't see k minus 2, I'm like, maybe I might have did something wrong. Guys, what does the bottom left cancel to? Or, factor to? Come on. Yep, k minus 3, k minus 1. Look at that. Coincidental? Nope, not. I don't think so. And then what else can cancel? K minus 3, k minus 3. Look at that. All of this, if we are concentrating on, first of all, factoring, and then finding the cancellation forms of 1, what does all this equal? 1/2. Done. Okay? Now let me do one where it's solving the equation. These are just simplifying. I want to do the ones that are solving, where there's an equal sign. I'll let you pick, and we'll do it together. 1 through 5. Which one do y'all want to do? I'll let you pick. Number 3. LCD is what I'm thinking. I'm trying to get rid of all denominators with one shot. What could I multiply both sides by that will get rid of all denominators? Can I multiply both sides by 7 and get rid of all denominators? No. Can I multiply both sides by 8 and get rid of all denominators? 56. But I can do 7 times 8, which is 56. So 56, aka 7 times 8, I'm going to multiply by that, and 7 times 8, I'm going to multiply by that. Watch, the reason why I do that is 7's cancel to a form of 1, and 8 is distributed on the rest. 40y minus 24. Look at this. 8 cancels to a form of 1. 7 is now distributed, so I get 42. Ooh. 42y plus 14. Don't forget the distribution. You need the parentheses. From here, I don't like to work with negative coefficients. I would see the 42's bigger, so I'd move this over here so that you have 2y left over. You with me? And then I would subtract the 14. Anyone, what was that? Or what's that? 38, right? So what's y? Let's do one more and we'll call it a day. 4 or 5, which one do you want to do? 5, here we go. I'm multiplying by a form of 1. You ready? The form of, oh sorry, not a form of 1, no. I don't need to do that because this is equals. I could do any numbers that I want. I can multiply the left by 2, the right by 2. Doesn't have to be 2 over 2 because of the equals. So I'm going to multiply by x minus 5, x plus 5. Difference of squares. There it is again. Over here, x minus 5, x plus 5. Because these will cancel. This is what's left. 3x plus 15. These will cancel. This is what's left. X squared minus 5x. Oh, here we go. Do I have one? Oh, my bad. I forgot the 1. So let's say this is... oh, okay. That's a big mistake. I forgot the 1. Let's make room for that. X squared minus 5x is going to come over here. And guess what I'm going to put here for 1? It's going to distribute on this one, and it's going to distribute on 1. I'm going to put x squared minus 25. I'm going to put the difference of squares, x squared minus 25, that I'm adding, and there's my equals. Do you see how the x's are going to cancel? Oh, sorry, the x squareds are going to cancel to 0? Can you see that? So x squared minus 25. If I get all terms on one side, first of all, real quick, I've asked you this question before. When you see something like this, should you think, man, I got to get this equal to 0? I think you should because, listen, you have an ax squared term and you have a bx. So when you start simplifying, those go to 0. So those go away. You move this over here, you get 8x. What's 15 minus 25? Negative 10. So when you move it on the other side, it's 10. And you get what? 5/4. Nicely done, guys. Good job today.